Okay, good morning. Yesterday we have started with the second module. The second module was relational database management. So, voice is clear? It's audible? Anybody?
Ma'am, you can show the full screen, ma'am. We can zoom.
Yeah, that's what I have shown the full screen only. Full screen
But
only I have done.
here we are not getting full screen, ma'am.
How come? I'm able to see the full screen. I've made it full screen only. Okay. In the second, at least my audio is clear. Any disturbance in my
Yes, ma'am.
audio?
No,
Is
ma'am,
it?
no.
Okay. Oh, okay. So, okay. In the second module, what did we start? Is what is there in the second module is relational model concepts. So, what is this relational model concept is? Uh, See now, whatever we take with respect to DBMS, we take that as a table. So instead of taking table, calling it as a table, here in the relational model, we call it as a, instead of table, we call it as a relation. So then what are the things which we see in the relational model? The relational model represents the database as a collection of relation. So here we call it as a collection of the relations. So whereas in the database or DBMS, we call it as a table, whereas here we call it as a relation. So what is this relation? There are huge sorry, what is this DBMS is doing is collection of relations, means collection of tables. So here in relational model, we call it as a relation and collection of so many tables. So we have already done with one program. So in that, how many five tables are there? But with respect to relational model, this, instead of calling it as a 5 tables, we call it as a 5 relations. So then relation is a mathematical concept based on the idea of sets. So why do we require this relational model is, so it is a mathematical concept where I want to add two tables, or I want to fetch some columns from one table and one column from another table. So that's how we do, that's what is called as a relation is a mathematical concept based on the idea of sets. The strength of the relational approach to data management comes from the formula, a formal foundation provided by a theory of relation. So that's what is called as a relational model concept. What's the strength of this? So we use a data in this. So then we use a formal foundations by the theory of relations. So here in this case, you can see one example. Student is one example and course is another example. Okay, course is another example. Section is another example. Grade is another example. Prerequisite for this database. What is the prerequisites we require? So this is how just 5 relations. So each one with the respect to DBMS, we call them as a table, whereas with respect to relation, we call them as a relation. A student is one relation and course is another relation. Section is another relation. Grade report is another relation. Prerequisite is another relation. So that's how we call it as a relations. So then what is relational model? The model was first proposed by who developed this relational model? It was developed by a Cod, Dr. E.F. Cod. He was working for an IBM company, in which year he published a paper in the year 1970, and he gave the title of the paper as a relational model for large sharp data banks. For communication, he has used, and he is published in a journal called as a ACM. So in June 1970, the above paper, whatever was there, was the revolution in the field of database management. And earlier, everything what they were doing is, so before this DBMS, everything they were keeping in a files. Now also you would have seen, you have, suppose if you have a project, what you do, you keep everything in the files. So before that, you were writing everything in a books. So that is how the same way here, files means something like your books, and your projects, what you are doing right now, everything you keep in your laptops. So that's how we can just term it or give the relation between these two. What is informally? How do we call the informal things? Informally, a relation, a table of values. What is a relation? Relation is a table of values. A relation may be thought of as a set of rows. A relation may alternatively be thought of as a set of columns. Each row represents a fact that corresponds to a real world entity or a relation. So how do we define all this? What is a relation? In that, how many rows we have? So now in your class you have 51 students. So each one of your details, I'll store it as one row. So then if I call collection, set means what? Collection of all your details, all 51 students, USN, name, subjects, which semester, what was the second semester score, first semester, all these I keep. So what we do is, so we keep one table first semester detail for your set of students, second semester details of this, third semester detail. So now these tables, whatever we keep, that is what relation. Then rows, 51 rows are there in the first semester also because you are 51. So then what we call it as a set of rows. So relation may alternatively be thought of a set of columns. Even we can call how many columns I have in your first semester, how much should I create before I should think. What I'll think, one is serial number, second one is your USN number, column, second column is your USN, third column is your name. And in your first semester, how many subjects you have? Or in your third semester, if we speak, how many subjects you have? You have 5 subjects and 3 labs. So then how many columns I have? Already have done with 3. One is serial number, USN, name. So another 5 plus 3. Totally how many columns I require just to add your all subjects? I want more than 10. So then what is this? Number of columns. That's a set of columns. Each row represents a fact that corresponds to a real world entity or relationship. Each row has a value of an item or set of items that uniquely identifies that rows in the table. Sometimes row ID or sequential numbers are assigned to identify rows in the table. So now your each serial number or your USN number. Why do you have your USN number? I call 0102. So what is that? So it says that your sequentially one after the other I call your names. When we are taking attendance, same way even in your rows also we represent them. Each column typically is called by its column name or column header or attributes. So what is column name? Your USN number. What is another column name? Name. So what is another column name? Subjects. So that's how we represent, that is an informal definition. And what is formal definition? A relation may be defined in multiple ways. The scheme of relation are, what is the scheme of relation? R. What is A1, A2, A3, A4? Those are the attributes. The relation schema R is defined over attributes A1, A2, etc., AN. So what is this? Relation is what? Multiple ways. I can represent in the form of rows, in the form of column. So then I say it as a relation. So then what is, how do we represent the schema of a relation? The description of your table is called as a relation. We know in the database terms, in the DBMS terms. Whereas with respect to relational model, we represent schema as R. What are the attributes? We represent them in a general form because we have so many tables. I cannot say student table like this, course table like this. So if first we generalizing it, we call it as a R. R is what? Relation. Then how many attributes we have? A1, A2, A3, keeps going AN. So then relation schema R is defined over attributes A1, A2, etc., AN. For example, customer ID. Then customer name, address, phone number. What is customer? Customer is one relation. What are the column names we have here? We have 4 columns. Customer ID is one column, but what we are calling it as an attribute. Then customer name is another attribute, address is another attribute, phone is another attribute. Here, customer is a relation defined over the 4 attributes: customer ID, customer name, address, phone number, each of which has a domain or a set of valid values. For example, domain of the customer in the digit 6. Suppose if we take, what do we mean by the domain? Domain means, let us see what is domain. What is customer ID? Customer ID, what is that? It is an integer. So I may take some number, some number. So then what customer ID, what it will be there, I may add even character also. It's left to me. Based on my project, I can change it. So customer ID, let me assume that I am taking it as a digits. What should be the size of the digit? I say it is a 6 digit. So then what is the domain from where I have taken from a domain set of integers? I have taken how many? I will take 6 digit at one time. That is what is called as a domain. Then what is a tuple? So tuple is an ordered set of values. So what is this tuple? One particular row in your relation, we call it as a tuple. A tuple is an ordered set of values. Each value is derived from an appropriate domain. So now I will say 1 BY 19 MCA 01. What is that? I'm fetching some value. Whose value it is? Third semester students ask us number, her USN number. So that's how it is called as a value. Each row in the customer table may be referred to as a tuple in the table and could consist of 4 values. So what is the customer have already told? There are 4 values. One is customer ID, customer name, address, and phone number. So this, whatever when I enter 632984, if I enter something like this, so I'll start entering. It's a pointer. Okay, so what I'm entering 6. You can see it as 632895. So what is this? This is the customer ID. What is this? This is a name of the customer. What is this? This complete is the address. Now what is this? This is a phone number. So what are all these? These are the values in some relation. Which relation? Customer relation. A relation may be regarded as a set of tuples or rows. A relation may be regarded as set of tuples. Tuples means what? Rows. Column in the table are also called attributes of the relation. So what is a column we are calling? We are calling it as an attribute. And we have seen these are some of the examples. Domain means, that's what I told logically. So how do we represent? Phone number. So if I say phone number, what should be the size of the phone number? I say it is a 10-digit number. So in the same way, I have some other things. So the same way, formal definition. A relation is informed over the Cartesian product of sets. Each set has value from a domain. That domain is used in a specific role, which is conveyed by the attribute names. For example, attribute customer name is defined over the domain of string of character 25. So what should be the size of your name? You have one table or one relation called as a customer. So we have a customer ID there and customer name. What is the size? Customer ID we told will give a 6-digit number. Then what is the size you are giving for customer name? We are saying it is 25 characters. Yes. So how do we represent formally? We say R. R is what? Relation. What is A1, A2, etc. AN? These are all the attributes. So now attributes means columns in your table. So always what we do? A relation. Small r is what? Relation. A set of relation R is a subset of. This symbol is what? Subset of domain A. What is this domain A? First column, what was the first column in a customer? Customer ID. So A1, if I say A1 is a customer ID. From customer ID, from where did we take? We have taken from a domain of integers. In the same way, domain A2. What is domain A2? If we take an example of customer name. So what is a customer name? We told customer name is a characters. What is the size of the character? 25. That's what is called as a domain of A2. So this is what is called as a domain of A1, domain of A2. Like this we keep going. That's what is called as a relations. Then R, schema of relation. R of R, specify value or population of R. Capital R is what? Intension. Small r is what? Extension of the relation. Suppose if we take a relation set as 0, 1, set 2 ABC, then R is a subset of S1 Cartesian product S2. So what is this subset? In this case, you can see how many combinations we can do with these two sets: 0 of A1, 0 of B, 0 of C, or 1 of A, 1 of B, 1 of C. So many sets we can do. But here in this case, you can see we have just taken one, not complete. So we have taken 0 of A, 0 of B, 1 of C. So then that's the reason you can see S1 in Cartesian product S2 is always a subset of the relation R. Is one possible state or population or extension R of the relation R defined over domains S1 and S2. It has a 3 tuples. So in this case, how many rows are there? This is one row, this is another row, this is another row. With respect to relations, what do we call? We call it as a tuple, one tuple, second tuple, third tuple. We represent it as a T1, T2, T3. That's what is called as a formal definition. So if we just map all this, so definition summary, so informal and a formal. So what is this? Informally, we call it as a table. Whereas in a formal relational, we call it as a relation. Column, attributes or domain. Row, tuples, values in the column, domain. Table definition, schema of the relation. Populated table, extension. So in this case, you can see these are all the attributes. So student, name, SSN, home, phone, address, office phone, age, GB. All these are called as a attribute. What is the name of the relation? The name of the relation is students. So whatever details we store it, this is one tuple, this is another tuple, this is another tuple, this is another tuple, this is another tuple. This is an example taken with the one relation called as a students. That's what is called as a attribute. This is what called relation, name, and these are called as a tuples. So characteristics of a relation, ordering of tuples in the relation. Okay, so now if I take an example, now I'll ask you people, stand yourself out of 51, stand in what the people who have born in January should come in the first, next month, February, next month, like that. Then what order you people have been asked to stand in the month of the month which you are born, or I may ask you people to stand with respect to your USN number. So one will start first, next two, like this. So then what it means is ordering in the tuples is not important, but only data is important. That's what here, ordering of tuples in the relation. The tuples are not considered to be ordered, even though they appear to be in a tabular form. So though they are in the tabular form, the order, it is not required for me. I told that USN 1, they must, I may keep it in the first row, or I may change it. I will say that based on your birth month, stand. So then what, the people who have born in month 1 will be first, then 2, then 3, like this it will go on. So the ordering may change, or I may ask you, based on your toppers in the class, arrange yourself. So that's what here, based on anything we can do it. That's what is called as a characteristics of a relation. So the second characteristic says that ordering of attributes in the relation schema. Same way, instead of columns, attribute keeping attributes also. Why should it be only first USN? Why not name? Why not like next your subjects, like this? The order can also change. So that's what here, the order also, it does not matter, but the values within that is required. Then values in the tuple, all values are considered atomic. So what do we mean by atomic is individual. There is no further division. Something like that is called as atomic. A special value, a special null value is used to represent values if I don't know. Suppose I don't know Asta's phone number. I don't know Rashmi's place. So then I leave blank. So that's what, if I don't know any values, then I write something called as a null. What does that null represent is, null says that I don't know right now the value. Maybe after that, after sometimes I may ask them and I can update. So that's what here null stands for. How do I represent the notation? So we represent tuple as T and attributes. So T of AI. So how many attributes are there? I attributes are there. Then Vi, the value of attributes AI for tuple T. Similarly, T, A of U, A of V, etc., AW refers to the subtuple of T containing the values of attributes AU, AW, AV, etc., AW respectively. So then student, name, SSN, home, phone number, address, these are all the one relation. So then what are the constraints? So now what is the constraints for you people for third semester? So you have a class from 8:30 to till 4:30 you have classes. So that is your constraint. So limitation for you. So in the same way, even in the table also, we have some constraints. So there are different types of constraints. We see them one by one. The constraints are conditions that must hold on all valid relational schema. There are three main types of constraints. What are the three main types of constraints? One is key constraint, another one is entity integrity constraint, last one is referential integrity constraint. We see one by one. So what is key constraints? Key is what? Like uniquely I want to identify all of you. So starting when you come initially when you join MCA course, then we don't know your names. First day. Later on, after 1 or 2 days, we recall what is your names. So that's what here. What was the first thing? That at that particular time, your name is a key for us to call. Okay, after some time, you will get a USN number. So then what is that? That USN number is a key. Uniquely, it will identify who is who. So that unique key here in relation, we call it as a super key. A set of attributes. So set of attributes, how many attributes you have? Your USN, your name, your subject 1, subject 2, subject 3, subject 4, like this we keep going. Then we represent super key as SK of relation R such that no two tuples in any valid relation instance R of R will have the same value of SK. That is, for any distinct tuples T1 and T2 in R of R, T1 super key are not equal to T2 super key. Means now you have your Asta is having a USN number 01. When Asta is having 01, no one else should have a USN with 01. You may have 02, you may have 03, but not. Only Asta is reserved for her number 01. So that is what it means here. That is super key. What is super key? Super key is a unique key which is used to identify each tuple in your relation. Okay. So then key of relation, this is called super key. Super key, I can combine it as Asta's USN is your one, your name and your age. I make it as one set. I call these three as super keys. Then what is a minimal in this key is your USN, I call it, if I remove I may make your USN and your name as one set, your USN and your age as another set. But still, this completely we call it as a super key. Key of a relation, a minimal super key, that is super key K such that removal of any attribute from K results in a set of attributes that is not a super key. So that's what is called as a key of relation. A minimal super key, that is a super key K such that removal of any attribute from K results in a set of attributes that is not a super key. For example, let us take an example, the car. So in the car, which state it is and register number. These two I am calling it as a super keys. So again in this super keys, which is a minimum is, I may take it as register number. So it has two keys, key 1 is state and register number, key 2 is a serial number. which are also a super keys. Serial number and making is a super key, but not a key. So if a relation has a several candidate keys, one is chosen arbitrarily to be primary key. So what is candidate key? Now I have state and register number. I have a serial number. I have a serial number and in which year they have manufactured, made. So like this, I may have so many. So in that case, if I have several candidate keys, then I arbitrarily take one as a primary key. You have your name, you have your USN. So then both are used to represent. But when we have your name and USN, which one we will take in the college as a primary key? We take it as a your USN as a primary key here in the college. But in your home, your name is a primary key. So that's how the relation based changes, even this is also changed. The primary key attributes are underlined. Always what we do, we underline the primary key. So you can just see here, this is one relation, that is what is a car. Car is one relation. In this, how many attributes I have? 1, 2, 3, 4, 5. There are 5 attributes in the car. How many tuples I have? 1, 2, 3, 4, 5, 6. There are so many tuples. What is license number? License number, because it is underlined, I am calling it as a primary key. What is this key? License number is a primary key. Sometimes I will make license number and engine serial number, both these two, as my keys. Then this is what is called as a key constraint. Entity relation, a relational database schema, a set S of relation schema that belongs to the same database. S is the name of the database. S equals to, so like this, how many relations I have in your first program? You have so many relations. We have so many relations. R1 is one relation, R2 is another relation, like this Rn. So then this we call it as a relation. So the entity integrity, the primary key attributes pk. What we represent primary key? We represent pk. Of each relation schema R in S cannot have null values in any tuple R of R. This is because primary key values are used to identify the individual tuples. So that's what here entity integrity. Entity integrity, a relational database schema. A set S of relational schema that belongs to same database. S is the name of the database. S equals to R1, R2, etc. Rn. Entity integrity, the primary key attributes pk of each relational schema R in S cannot have null values in any tuples of R of R. This is because primary key values are used to identify the individual tuples. T of pk not equal to null for any tuple T in a R. Note that the other attributes of R may be similarly constrained to disallow null values, even though they are not member of primary keys. What is referential integrity? So what is entity? So the entity is a primary key attributes that we represent. So then what it should be in that? Always the primary key, whenever I say primary key USN number, I cannot make USN number as null. Means I cannot leave blank. That is what is called as a entity integrity. So then what is referential integrity? A constraint involving two relations. The previous constraints involve a single relation used to specify a relationship among tuples in two relations, the referencing relation and the referred relation. There are two tables. One is a table having a primary key, another table which you are referring that. That is what is called as a referencing relation, referred relation. That's what referencing and referred. The tuple in a referencing relation R1 have attribute fk. What is this fk? Fk means foreign key. That refers the primary key attributes pk. What is pk? Pk is a primary key of a referenced relation R2. A tuple T in R1 is set to reference a tuple T2 in R2 if T1 foreign key equal to T2 primary key. That's what is tuple, foreign key, and a primary key. A referential integrity constraint can be displayed in a relational database schema as directed from R1 FK to R2. So referential integrity constraint, statement of constraint, the value in the foreign key column Fk, so what is this? Foreign key of the referencing relation R1 can be either 1, a value of an existing primary key values of the corresponding primary key Pk in a reference relation R2, or a null. In case 2, the Fk in R1 should not be part of its own primary key. So that's what is called as a referential integrity constraint, statement of the constraints. So this is what is called as a referential integrity constraint. Then other types of constraints, what are the other types of constraints? Semantic integrity constraint. So how do we see, based on the application semantics cannot be expressed by the model per the session. So example, take an example. The maximum number of hours per employee for all the project he or she works is 56 hours per week. So this 56 hours, again it depends. So maybe Wipro may ask you to work for 56, but TCS may ask you some other hours. So then I cannot fix this. Based on your projects, we can change. So one more, the constraint specifying language may have to be used expresses these. So SQL 99. So some people may say that we will be using SQL. Some people may be saying that I'll use MySQL. Some people may say that I'll use MongoDB. So it's left to the projects what type of database tools you are using. So some says that I'll be using triggers. Some says I'll be using assertion. Like this, these are the different types of constraint based on the different types of database what we use. Then how do we represent a schematic diagram for a company relational database? So a company is employee, department, department location, project, works, dependent. So in this, primary keys are underlined. You can see in the employee, SSN is a primary key. In department, D number is a primary key. And department location, department number and D location is a primary key. In the projects, P number is a primary key. In the works on, these are the two reference keys. Dependents, social security, employee social security number and dependent name is the two keys, but not primary keys. These two are a reference keys or foreign keys. So that's how we say how these are underlined. There may be keys, primary keys, or there may be a foreign keys also. Okay, so then how do I represent a table? This is how we represent a table. So just now we told what was the headings. This was a heading: first name, middle name, last name, social security number, birth date. So what are the values we have? This is what is called as a schema diagram. So this we call it as an instance. Instance means what? The value stored in the table is called as an instance. So one possible relational database state corresponding to the company schema. So how many right now are there? Now, right now in a company, these are the employees. Maybe today or tomorrow, John may leave the company or some other person will be adding. So like this, this instances can change, but this will not change. Why? Because this is constant. In a employee will be having name, middle name, last name, social security number, birthday. This will not change. Only this instances will change, because today there may be one person, tomorrow there may be another person joining the company, leaving the company. So that's how the instances states of the relational database can change based on some circumstances. In the same way, the departments. Right now there are 3 departments. Maybe tomorrow we may add one more. So like in BMSIT we have added AI and ML. So now we would have added one more row in this. So then it is a possible. Then the state of this department from 3 to it will change to 4. So like this, it keeps changing the value. Okay, then how do we use a referential integrity constraint? What do we mean by reference? Just now we saw that referential means what? Foreign keys. When do we say foreign keys? When we have a primary key, and when we are referring that, then we are calling it as a referential integrity constraint. Now take an employee. In employee, what is a primary key? SSN is a primary key. Then in department relation, D number is a primary key. But here you can see in the employee, one employee is working for department. Now I am working for some department, MCA in BMSIT. That is a department. What is a department number? Maybe 1. So this is what here department number is. So your department number is primary key in this department table. In this table, SSN is a primary key. In department location, these two are the foreign keys. And in project number is a primary key. Works for, these two are the foreign keys. Dependents, again, these two are the foreign keys. How these I am referring? So you can see, what is this? This is a self-referential number because SSN, this is a primary key. And this supervisor SSN number for each department, maybe now your HOD is also an employee in the BMSIT, but only one HOD or one principal is there. Then what is that? They are the supervisor, right? But they are the employees. This is called as a referential or self-referenced constraints. So we are referring like this. Now D number. From where we are taking this D number? We are taking D number from a department. So then managerial social security number. From where? From here. Social security number we are taking. Then department location we are taking D number, and here projects also for which, what is the project MCA students are doing, that is what the D number, which department MCA. How many hours they are working, what is the social security number, what is the project number. So these all we are taking from each of these tables. So this is called as a referential integrity constraints. So I'll just stop here. I will continue in the next class. Asta, answer your question. Before I take the attendance, I want every one of you to complete this quiz. So I'm pasting again. The people who have joined late also can complete your quiz. Abhinav?
Present, ma'am.
Aishwarya?
Present, ma'am.
Amresh?
Yes, ma'am.
Anu?
Present, ma'am.
Arbaz?
Present, ma'am.
Arjun?
Present, ma'am.
Ashok?
Present, ma'am.
ಯಾಕಪ್ಪ 2 ದಿನ ಬರ್ಲಿಲ್ಲ ಅಶೋಕ್, ಎಲ್ಲೋಗಿದ್ಯಪ್ಪ?
ಇಲ್ಲ ಮ್ಯಾಮ್, ಸ್ವಲ್ಪ ಪರ್ಸನಲ್ ಪ್ರಾಬ್ಲಮ್ ಐತಿ.
ಹೌದಾ? ಓಕೆ, ತಿಂಡಿ ಆಯ್ತಾ?
ಹಾ ಮ್ಯಾಮ್, ಆಯ್ತು. ನಿಮ್ದು ಮ್ಯಾಮ್?
ಆಯ್ತಪ್ಪ. ಬಿನ್ನಿಟಾ?
Present, ma'am.
ಭಾರ್ಗವಿ?
Present, ma'am.
ಭವಿಷ್ಯ?
Present, ma'am.
ಚೈತ್ರ?
Present, ma'am.
ದೇವ್ಮಲೈ?
Present, ma'am.
ದೀಕ್ಷಾ?
Present, ma'am.
ದೀಪಿಕಾ?
Present, ma'am.
ದೀಪಿಕಾ?
Present, ma'am.
ಮುರಳಿ ಕೃಷ್ಣ?
Present, ma'am.
ಗಂಗೂಬಾಯಿ?
Present, ma'am.
ಗುಜಿಯಾ? Gujiya, she was there, right? But what happened? Harshit?
Present, ma'am.
Junjar?
Present, ma'am.
Kavya?
Present, ma'am.
Kishore? Kishore?
Ma'am.
Yesterday you were absent,
Present,
sir.
ma'am.
Yesterday you were absent, sir. Why, sir? Why, sir? Kishore? Ma'am, what is, sir? What, sir? Why, sir, you didn't come yesterday? Huh? Okay, Lata,
Yes, ma'am.
Manisha,
Present, ma'am.
Manjunath,
Yes, ma'am.
Nayana,
Yes, ma'am.
Nilanjan. Nilanjan, what happened to Nilanjan? Why he is not coming? Why he is not attending? Even yesterday was not there. Friend of Nilanjan, please ask whether he's okay. We just want to know whether all are safe. Nishant,
He's okay, ma'am.
okay. Pavitra,
Present, ma'am.
Maithili,
Present, ma'am.
Priyanka,
Present, ma'am.
Pavan,
Present, ma'am.
Akash,
Yes, ma'am. Present, ma'am.
Rajeshwari,
Present, ma'am.
Rakesh,
Yes, ma'am.
Ramya,
Present, ma'am.
Rashmi,
Present, ma'am.
Ravi, Ravi, Ravi is absent. Rizwan,
Present, ma'am.
Vishal,
Present, ma'am.
Savita,
Yes, ma'am.
Shruti, Shruti.
Present, ma'am.
Yesterday, madam, where you were? What happened yesterday?
I'm present, ma'am. Yesterday, even I attended, ma'am. Yesterday also.
But you didn't answer the attendance. Sneha?
Yes,
Okay,
ma'am.
marked. Marked. Spurti?
Present, ma'am.
Srinidhi?
Present, ma'am.
Srinivas?
Present, ma'am.
Sunil?
Present, ma'am.
Vaishnavi?
Present, ma'am.
Vinny?
Present, ma'am.
Ma'am, present, ma'am. Gudiya, ma'am. I
Yeah,
have
marked.
sent you.
Yeah, marked Gudia. Okay. So hope so everyone has done with your this one Google for quiz for today. But someday I have seen that some of you have not done. What was the reason?